So dangal greetings everyone, my name is BJ Albacalonia and I'm gonna explain the loading screen class in Java. So the loading screen class is a Java Swing based user interface that serves as a loading screen for an application. It extends JFrame and utilizes components such as JPanel, JLabel, and JProgressBar to visually represent the loading process. The frame is undecorated, meaning it does not show the default window borders and title bar, giving it a cleaner look. It says a custom icon image using toolkit, and the size of the window is defined with specific bounds. A static JProgress bar is declared so it can be updated from the other class while the application loads. Inside the constructor, the content pane is created and given a new layout for absolute positioning of components. A label display is added to inform the user, and it is styled with a bold font and black color. The yellow progress bar is placed beneath the text to show the loading progress visually. Additionally, an animated GIF is displayed using a J label with an image icon, serving as a dynamic element to indicate activity. Finally, the window is centered on the screen using set location relative to null, ensuring it appears at the center of the user display. Next is the LoginEntry class. So, the LoginEntry class is a Java Swing-based graphical user interface that functions as the login screen for a system. It extends JFrame and features a login form where users can enter a username, password, and select an access level from a combo box: admin, customer, or staff. The layout is built with absolute positioning, and UI components are added to a JPanel with no layout manager. The username and password fields are placed alongside corresponding labels styled in white bold font. When the user clicks the login button, the program checks the entered credential against hard-coded values for each user role. If the credentials and selected access level match, example admin, for both username and password with admin access selected, the user is successfully logged in, shown a confirmation message via J option pane, and redirected to their respective frame: admin frame, customer frame, or staff frame. Otherwise, an error message is displayed, and the input fields are clear. The cancel button simply closes the login window. Additionally, background and logo image are loaded using relative paths to enhance the visual design. Finally, the set location relative to null center the frame on the screen when it launches.
Donald, greetings. My name is Justin Mikan Aguilar, and the next topic that we will discuss is the public class mainframe. Now, over here we have the imported Java for the event script, which handles GI related codes and Java Swing components. Over here we have the public class mainframe, which inherits everything from the JFrame, and we have here an empty constructor to be later added in the code when initializing UI elements. And then next we have public static final long serial. So its lets objects be saved to the disk or sent over the network when extending the JFrame. We have here the private panel content pane, which will be set for the main container for all GUI components. And the next one we have here a public static int ID counter, which shares across in all instances, all IDs starting at 1, and private fields with variables to use the name, int age, and double money. And this is our main method. Over here we have the loading screen, which creates a new window or panel on the loading screen, which makes it visible like a progress bar over here, which sets the visibility to true. And then it initializes the loading from 0 and then starts from 0 and keeps looping. We have here a try catch method inside it. We have a while loop. When the loading counter is less than 0 equal to 100, it will keep looping. So, and then sets the value of the progress bar in a loading screen as it moves. And then have a delay of the progress loading. Then next, here it checks if the loading counter is equal to 100. It then disposes the loading screen. So after disposing the loading screen, it will then start to show the new window, which is the login frame over here, and which sets the visibility to true. And then here's the incrementing loading counter. And here is the catch, which indicates if any interruption is made or when the X button is pressed or an interruption made. Greetings, my name is Justin and the next topic that we will discuss is the public clash test. And then over here we have the private fields with the variable name, string name, public price, string category, and in quantity, which is set to 1, initialized 1. And we have over here the constructor with the parameters string name, double price, and string category, which pertains to over here. We have the overloaded constructor, which sets the quantity. And then over here we have the getters and setter method. We have the getter get name, get price, and get category. We also have here the getter setter for the quantity, which is the get quantity, the set quantity, and the override method, or the string method. So it will display the name, the category, and the price. Like for example, pizza main dish and $12. Like that.
Hi, greetings everyone. My name is Carl Lorenzo Ibagos, and also you can call me Lou. So right now what we are going to do is to explain to you the customer class. As you can see here, we have the customer's name, the customer's ID, table number assigned to the customer, and list of dishes the customer has ordered. So we've already initialized for that one, specifically for this for private access variables. Okay, so we also have the constructor, so that to initialize a customer with name, ID, and table number, of course, and also for okay, so for this is a method. Yes, this is a method to remove, to add a dish to the customer's list, and also to remove an order to the customer's list. Okay, and also for the getter and setter methods for the following variables on our constructors. And let's jump to the next one, which is this. Okay, yes, getter for the list of dishes ordered, and also setter for the dish list. Okay, of course. So for this one, as you can see here, we have a method here named calculate total. So it means it only calculates the total cost of the combined ordered of the customer, of course. Okay, so that's the purpose of this calculate total. So as you can see here, we have the keyword override. So it means it overrides the it overrides the methods of the other classes. Okay, public string to string. So this only means that this toString method is it translates the datas that have been stored to the to our array list. Okay, so that's all for the customer class. Thank you for listening to me. Once again, please listen to the next presenter. Okay, thank you.
My name is Mark Denzel Anilas, and today I will explain to you the customerFrame.java. This customerFrame class will serve as the interface of the foods, and I separate them by three categories: the main dish, dessert, and the drinks. And after that, I initialize a boolean variable to track whether the buttons are being clicked. And in this constructor, we create a menu bar to be able to log out and set an action listener to execute a function. As the other button has been declared, we put an action listener to every one of them. And that when it's clicked, a string variable name category is declared as the same as the name of the dish, the price, and create a dish object that have a same parameter of the name of dish, the price, and the category, and add them in the customer storage. And also set the nearby buttons to become disabled when the other button is being clicked. This is to ensure that one dish per category of for one customers, and the And the logic applies to all of the buttons, except to the My Cart and the My History button. And the My Cart button is able to track whether the button from the category is being clicked, and calls the MyCartFrame objects that produces a table to display the dish being ordered. And lastly, the My History button that displays a table to track the order.
Greetings everyone, I am Janeline Bessa, and now I'm going to explain the MyCartFrame. The MyCartFrame class is a graphical user interface or GUI window built using Java Swing that serves as the shopping cart view for a customer in a food ordering application. It extends the JFrame class to create a standalone window titled MyCart, which visually represents the list of dishes a customer has selected for purchase, organized into a table displaying each dish's name, price, and category. The interface includes a label to show the total cost of all items in the cart, calculated dynamically from the list of dishes the customer has chosen. It also features a Pay Orders button, which triggers a payment process where the user is prompted to input their payment amount. The system then checks if the payment is sufficient, calculates the change if needed, categorizes the dishes into main dish, drink, and dessert, and generates a receipt displaying the details of the transaction. Upon successfully payment, it logs the order into a history list and an order list for stop processing, clears the customer's cart, resets the menu buttons in the parent frame, and disables further payment to prevent duplicate processing.
Greetings everyone, I'm Stefan Diagio and I'm going to talk about the order class. The order class represents a customer's food order in a simple ordering system. It includes fields for the main dish, drinks, desserts, and a unique order ID. The order ID is automatically generated using a static counter variable that increments with each new order, ensuring that each instance of the class has a distinct identifier. Although the constructor accepts an order ID parameter, it is not used. This is likely a mistake or oversight as the actual order ID is assigned internally using the counter. The class also provides a to-row method which returns the order details in the form of an object array, making it suitable for displaying in tabular structures like a JTable in a GUI application. So the class provides a basic structure for managing and displaying order data. Thank you. So now, I'm going to talk about the order data. The order data class serves as a simple data container for managing a collection of order objects. It defines a public static array list named orders, which acts as a shared list that can store all the orders created during the program execution. Because the list is static, it belongs to the class itself rather than to any specific instance, allowing other parts of the application to access and modify the same list without needing to create an object of order data. This makes it useful for centralizing order data, especially in small applications where a global list of orders is needed for tasks such as displaying, updating, or processing customers' order. Okay.
And now I'm going to explain the MyHistory class. This program creates a user-friendly graphical window titled MyHistory using the Swing library, which is designed to display a detailed and scrollable table of past food orders made by the user. It includes elements such as a large centered title label, a scroll pane containing a table with predefined column headers like History ID, Main Dish, Drinks, Dessert, total payment, and change, and dynamically fills the table with rows of data from a shared data source called HistoryData.histories, where each entry is assumed to be an instance of a history object that can be converted into a table row using a method called toRow, all while ensuring the window is nearly laid out, has a custom icon image, is centered on the screen, and properly disposes of itself when closed, making it an organized and accessible way to review previous food orders.
For the continuation is we have a history, public class history. So in this class we have this class name history. It will represent the one record of a food order, including main dish, drinks, dessert, total price, payment, and change. So for our static counter, private static int counter equal 1. This is a shared number for all history objects. It will start at 1 and increases each time a new history is created. It is used to automatically assign unique IDs to each record. So next we have a variable fields, private and ID to private double change. So these are the detailed storage for each order. ID is unique ID number auto-generated. Main dish is the selected main dish, example chicken. Drinks are selected drink, example Coca-Cola. And dessert is equal selected dessert. So it means example cake. And total is the total cost. And the payment is how much money the customer gave. And the change is money returned to customer. So next we have this, our constructor, public history string main dish, string drinks, string dessert, double total, double payment, and double change. So this is a constructor. It runs when you create a new history object. It will set the values for the new record. So this .id equal counter plus plus assigns a unique ID and then increases the counter. So for our getters, these are the getter methods. The public int get ID, get main dish, get drinks, get dessert, get total, get payment, and get change. So they allow other parts of the program to access the values, read only, and for example, history.getDrinks will return Coke if that was selected. So if you get dessert, for example, it will get return the cake. So for our setters, public void set payment and set change. These are our setter methods. They allow changing the value of payment and change later if needed. So our toRow method, public object toRow, return new object. This method is used for displaying the record in a table like a GUI. It returns all the details as an array object, ready to be added to a table row. It formats the total, payment, and change as a peso values with 2 decimal places. So what is simple example use? So example is where history, H1 equal new history. Fried chicken Coke cake, 150 pesos, 200 pesos, and 50 pesos. History data that history is add H1. So it will create a new history record added to the shared histories list in the history data. So in short, history class is like a receipt for one order. It stores the food, drinks, price, payment, and change. And it gives each order a unique ID automatically. And it will lead to other parts of the program get or change the payment and change. It also provides a toRow method to make it easy to show the data in a table format. Dangal greetings, Sir Patrick. My name is John Dorsal Ascension. Now I'm gonna tackle our class history data. So first into this, the important statement of our code is import java.util.arraylist. So this line tells the Java that we want to use the arraylist class from the Java util package. And the arraylist is not a basic type in Java. It's a special class used in store a list items that can grow or shrink. And think of it like a dynamic container that can hold multiple values of a specific type, like a list or a flexible array. So next is our class declaration, public class history data. This line starts at the definition of a class named history data, and the class is like a blueprint for objects. In this case, history data is a blueprint that will hold history records. And the keyword public means this class can be accessed from any other classes anywhere in the project. And for our static arraylist field, we have a public static arraylist, history is equal new arraylist. This line creates a public static list named history that hold history's object. So the public can be accessed from outside this class, and the static belongs to the class itself, not to individual objects. And this means you can use history data that histories without creating a history data object. And the arraylist history, a list that can hold multiple history of objects. So the equal new arraylist, this creates the actual list in memory, so we can start adding history items to it. Greetings, Sir Patrick. My name is Janor Sylvia Ascension. So today I'm gonna tackle our class adminFrame. So first is we have a class definition. Public class adminFrame extends JFrame. This class is an admin dashboard window, and it will extend JFrame to make a GUI window. So for our global variables, we have a private JPanel content pane, private JTable, private default table model. So the content pane is the main layout area where your UI components are placed. And the table is a table to show all the history records. And the model is to control the rows and columns in that table. So for our constructor is a public adminFrame. So these methods will create the entire admin window. And next is our window settings, the set icon image, set default close operation, JFrame exit on close. So this will set the logo, close operation, and the size of the window. So for our next is the menu bar setup. So the J menu bar equal new J menu bar. It will create a top menu with one item, logout. And next is the logout. Our logout action is the NNTM admin logout that add action listener in confirm. So it will confirm if the admin really wants to log out, and it will close the windows and opens for the login screen. So for our content panel setup is a content pane equal new JPane. It will set up the main container to hold all UI elements, and it uses to no logout manager like null layout for manual positioning. So for the next is the scrollable table setup. We use this method scroll pane equal new JScrollPane. It will add a scroll bar to the table so large data can be seen easily. So next is a table model and columns. So this block of code, string columns equals select status order ID, main dish, drink, dessert, payment, and change. So it will basically create tables, headers, and let's column 0 be checkboxes, and all other columns are read only. So for our label for the title, we use JLabel LBL order Q equal new JLabel record log. So it will add a large label at the top saying record log. So for our buttons, we have these edit buttons, J button, BTN edit equal new J button edit. It will add a button for editing records. And next is the edit action of our button. So BTN edit that add action listener. So this will check if a row is selected and prompts for a new payment, update payment, and recalculate change. And it also refreshes the table. So for our delete button, we have a J button, BTN delete equal new J button delete. It will add a button or to delete the records. So for the delete action of this is we use this method BTN delete that add action listener for this block of code. And if it check if a row is selected and it confirms before deleting or removing it from the list and table. So for the daily sales report button, we use J button BTN daily report equals new J button daily sales report. It will add a button to show the total sales. And next is a daily report action of our button. So BTN daily report that add action listener E double total sales equal to 0 int orders today equals to 0. So it will loop through all history records up to totals and count orders, and it will show a pop-up with the report. So we have now next is load history data. So private void load history data model that set count 0. This method refreshes the table with updated data from history data histories. So for our continuation, so I'm gonna explain the staffFrame. So first is we have this import statement. Import java.awt.eventQ and import java.swing. So this important the necessary libraries for creating GUI components like frames, panels, button, and tables. And the J option pane, JTable default table model helps with GUI dialogues, tables, and data models. And toolkit is used to set an icon for the frame. So the next is the class declaration. Public class staffFrame extends JFrame. This defines your main GUI class name staffFrame, and it extends JFrame, meaning this class is a window frame in your app. So for our instance variables, private JPanel content pane, private JTable and table unfinished, and private JTable table finish. So for the content pane is the main container where UI components are placed, and the table unfinished displays order that are not yet finished, and the table finish displays completed or server orders or served orders wala po, sorry. So the next is the constructor staffFrame. So the public staffFrame. This is the main constructor that builds the window when called. And the set frame of properties, we have set icon image toolkit that get default toolkit that get image images logo JPG. So it will set the icon image on the window, and it will set the closest operation exit the program, and it will set the window size and position. So for our menu bar and logout, we use this method J menu bar equal J menu bar and set J menu bar. So this block adds a menu bar with a menu and a log out option. When it will click, it asks the user if they really want to log out. And if it confirms, it closes the staff windows and opens the login windows. So for our setup content pane layout container, the content pane equal J new pane, content pane that set border, new empty borders 5555. So the content pane is the base panel for placing other components, and it will set layout to null, allows manual placement to using set bounds. So for our unfinished order table, we have a J scroll pane unfinished equal new J scroll pane. A scroll pane is created to hold the table for the unfinished orders. Next is the column headers. We use string column name unfinished, select status order ID, main dish, drink, and dessert. So it will defines the header for each table, and the table unfinished includes a checkbox column to select orders, and the table finish shows the complete orders and no checkboxes. So for the table models, we use this code of default tab model unfinished model equal new default table model null column name unfinished override public class and override public boolean. So it will create a table model that allows checkboxes in the first column boolean.class, and only the checkbox column is editable. And next is the default tab model finish model new default tab model column name finish D. As well this model is for finished orders. No cells are editable here. So next is the create and attach for our table. So we use table unfinished equal new JTable unfinished model. So it will create a table, connects it to the scroll pane, and for order data that orders add unfinished order order.order ID. It will load order from a list OrderData.orders and adds them to the unfinished table. So for the finished order table, we use jscrollPane, scrollPane finish equal new jscrollPane. So it will create the finished order section also in a scrollPane. And for the label for our section, we use this JLabel, label order queue equal new JLabel queue. It will add a queue and serve title above the tables. And our done button logic is we use this jbutton btn done equal new jbutton done. btn done that add action event listener new action listener. So this block of code is when the done button is clicked, it will check each row in the unfinished table. And if the checkbox is checked, it copies the data into the finished table with status done and removes the row from the unfinished table. So the summary for this is the purpose of a GUI staff to manage food order is to unfinished orders and can be selected and marked as done. And the finished order are listed separately and has a logout function with confirmation.